All right, here's a video 9.5. Dilutions. The equation for dilutions is similar to the molarity lesson. Quite simple. M1V1 is equal to M2V2, and that's it. That's the equation. That's the only real thing you have to know in this lesson. The rest is just knowing how to solve problems. Now, do note these subscripts 1 and 2. 1 is referring to the original solution, whereas 2 is the diluted solution. And so therefore M1 is the molarity, right, because capital M is molarity of our original solution, and V1 is the volume of our original solution, whereas M2 is the molarity of our diluted solution, and V2 is the volume of our diluted solution. Now, we can apply this formula, therefore, and do some problem solving in our practice problems. Now, do note, as I was looking at this, actually, the first 7 are really molarity problems. And so I'm going to give you guys, in your extra practice problem, I'm going to give you guys a couple, or really give you guys more dilution problems, because it looks like you have a lot of molarity here, but we only have 5 or so dilutions. And so I'll give you guys a couple extras to be able to work around and play with, but let's do number 8 first. Number 8, it says, if I add 50 milliliters of water to 145 milliliters of a 0.25 molarity LiOH solution, what will the molarity of the diluted solution be? And so, to do this, first always write out your formula. 1V1 is equal to M2V2. If I add 50 milliliters to 145 milliliters of a 0.25 molarity LiOH solution, what will the molarity be? Right, so let's you know, whenever you're reading these problems, you want to kind of try to harvest as much information as you can. And so it's saying you have 145 milliliter solution, right? Remember, the M1 and V1 are the original, right? So at the original, at the beginning, we have 145 milliliters. Now, I always like to change everything to liters. And so we have 0.145 liters. It's just a good habit to kind of be in, because if you're in molarity, then you have to be in liters. And so I'm in the habit of always being in liters. But, you know, hey, if you want to do milliliters, that's fine. Okay, so we have 0.145 liters. And the molarity of that solution is 0.25, right, of the original, right? M1 and V1 are of the original. And so it's saying, what will molarity be? So M2 is, we don't know. And it's saying if you add 50 milliliters. Now, do note, V2 is not 50. It's going to be 0.145 plus the 50, which is 0.05, right? So 145 plus 50, which is equal to 195 milliliters. And so that's 0.195 liters, right? So please read your question carefully. If I add 50 milliliters, and so now what we're doing is we're solving for M2. And so we're going to divide by V2 on both sides to get rid of that. And so we have M2 is equal to M1 V1 divided by V2. Then we just plug in M2 is equal to 0.145 liters times 0.25 moles over liters, right? Because that's what molarity is, divided by 0.195 liters. All right, then we are going to have liters cancels divided by liters, and so we have just moles over liters here. We're gonna put that on a calculator. 0.145 times 0.25 divided by 0.195, that is equal to 0.186. I technically don't have that many sig figs. 0.19 moles over liters. And there you go. That's molarity. And so you see, the hardest thing really is what we did here, right? This harvesting of information, and then we can just plug it into a formula. So let's do one more for good measure. Number 9, how much water will I need to add, right? So it's saying basically kind of V2, but not really V2, right? It's saying what will we need to do to volume. If we have 150 milliliters, right? So that is V1 of a 0.45 molarity LiF solution. That's M1, right? That's our original. In order to produce 0.25 molarity LiF solution, right? To produce, right? So that's the future, that's the diluted. And so that is M2, right? And so we're going to solve for V2, kinda. Again, I'll explain that in a second, right? And so M1 V1 is equal to M2 V2 And so we're going to solve for V2 by getting rid of M2 on both sides. And so we have M1 V1 divided by M2 is equal to V2 0.45 molarity times 0.15 liters divided by 0.25 molarity is equal to V2. Put that into our calculator, and we get 0.45 times 0.15 divided by 0.25, and we get V2 is equal to 0.27 liters. Now do note, that's what we are, like, we're gonna go from 0.15, right? That's what we had originally, to 0.27 liters, right? But the question is asking how much water will I need to add, right? And so to go from 0.15 to 0.27, what do we add? Right, we're adding 0.12 liters, right? We're add 120 milliliters. And so you have to read the question, right? Make sure you're answering the right question. If you put 0.27 at the end, you'll get most of the points. Like, you know, if it's a 4-point question, 3 out of 4 or 4 out of 5, depending on how many points it is, right? Probably 3 out of 4, actually. I normally grade out of 4. But the point is, right, make sure to actually answer the question, right? This is, you're gonna add 120 milliliters to go from 0.15, which is V1, to 0.27, which is V2, right? Make sure to answer the question. And right, we know how to interpret these numbers, right? It's like, okay, we had this, we're going to this, so we have to add this. How much water will I need to add? Add this much. Cool. Okay, so that's dilution problems. They're really not hard. They're just, make sure to read the questions, okay? I'll add some more for you guys for extra practice. Let me know if you have any questions. But do your practice. Mozart didn't become Mozart by watching people play the piano. You have to play the piano, right? I'll keep reminding you guys of that. Do your practice. Struggle through it. Struggle well. And you'll do great. You'll be great chemists.